Yeah, my name is Liu Liping, and I'm affiliated in University of Helsinki. So today my talk is about the evolution of human niche size in East Asia over the Pleistocene. And I'm paleontologist, so you know it's like fossil mammals. It's always a good evidence to reconstruction for the past climate, but it's not always easy and straightforward. And traditionally, people are used to species occurrence. So, for example, nowadays we know like house they live in the open habitat. So we assume like the early house they also live in the similar habitat, but it's not always correct. If you go deep to Middle Miocene, that house already live in the forest. So that's you can't do your research for a longer like time scale. So in the last 20th century, so more like climate reconstruction work, we used more like dental trait model. So this is advantage because first they are relatively independent with the taxonomy, and also you can use for the large temporal and the spatial scale. And yeah, so thanks for the date. So nowadays we have a lot of data available. So we have the wild animals live in one area, and meanwhile you also get all the environment variables. So for the temperature, precipitation, productivity, so all this, then it's possible you do the data mining to explore the association between the mammal community and the climate. And of course, after you build this model, you can use for the past. So for the fossil occurrence, of course, in the very recent, you can use the species also, but in very deep, for example, like a Middle Miocene, you can only use this use this ecometric method. And it's a very, from the very beginning of paleontology, we already noticed like some mammals, they really adapt to the climate and very successful. So for example, the horse. So if you see the evolution of the horse, this is a very classic story in your, not story, it's knowledge in the textbook for the evolution. So you see from the like early age, all the horse, they have very low teeth. But then after the late Miocene, all the horse, they have very high crown teeth. We call it hepsodont teeth. So that means, since you are not very familiar with fossils, so I just show you like this, they have very long teeth, like this. Why they have this? Because they eat very abrasive food. So this food erases the teeth very fast. So if you don't have it longer enough, you will dead very fast before you can have next generation. So that's why it's a successful adaptation. And even for the like a browser who eat much softer teeth, they also, you see the teeth also worn in some age. And we use this hepsodont for many studies. So we use that to resolve regional patterns for Eurasian climate, and also we try to capture for the aridity, because that's a very significant climate event during the Miocene. And also we do to use that to estimate for the precipitation and use for modern and for the fossil. And also we use that to estimate for the productivity and the biomass. So that's, we don't need to go deep. If you are interested, of course, you can look for the articles. So after the hepsodont, so we are thinking, okay, since the tooths are so important for their diet, so we want to also, we are quite sure like the morphology of the tooth surface, they are also important for the climate. So then we score more like a dental ecometrics. The method is easy, so except this hypsodont, we also score for other characters. So for example, if the cusp are bonodont or they have lorphodont tooth. So if they have the character, you put 1. If they don't have, you put 0. So in this sense, this tooth morphology can transfer to the value. And by this, so we use, for example, we have a set of the dental ecometrics. In another way, we have a set of this climate variability. So for each grill, analyzed grill, you have 2 sides of these variables. And then, of course, you can explore the correlation between the mammals and the climate. So we use both modern date for the animal for the climate, and also we use the fossil for the past and the paleoclimate simulation from the climate modeling. And this last year paper, they deal with the neogen, so I don't go detail. But from this work, we found 2 dental ecometrics are very prominent to correlate to the climate. So one is the hypsodont we already use for many studies, and another is called bonodont. So it means that the teeth cusp is still round and separated, so they are not became the lorphodont. So if you have the bonodont, you got 1. If it's lorphodont, you got 0. So because these are many like pigs and the primates, they have this kind of bonodont teeth. So they are special for the fruit eater. So they are living in the fossil habitat. So that's all from very long history, from very root of our understanding of the paleontology. And we use this because we are interested to understand the early Homo, their habitat and the ecology niche, to answer the biggest question like why and how the early human migrate outside Africa. Because yesterday my colleague Alex, he also talked Dmanisi to deal with the habitat for the Dmanisi. And so there are 2 different opinions. One is the grassland hypothesis. So people suppose the early human, they are prefer for the open habitat. They disperse along the grassland. And another is different, because more on this Asia fossil sites nowadays they reconstruct a more close habitat. So now there are more articles to argue for the grassland hypothesis. So we want to explore to answer the question. So why or what kind of the habitat the early human come to Eurasia? And so this article is led by a PhD student. He used she used all the literature published between 2000 to 2020 to see how the previous work they got the conclusion. So by the end, you can see most the literature, they use different proxy and do the reconstruction for the habitat, and most work their support for this grassland. So this year, so we worked together and used the hypsodont to test for this. So in these articles, we use all these fossil sites, both has the Homo fossils and the artifacts. So, and then to see how the hypsodont distribute. And then we separate Africa, Levant, Caucasus, and Asia, and Europe. And by this, still the early Homo, they seems prefer relative open habitat, but Asia are very specific. You see, it's don't like other continent human seems to have some predominant habitat. Asian shows very specific this bimodal pattern. So then if we look in detail, like this very dry end is like all represented by the lithtic artifact. And the human end is all represented by the Homo fossil site. So these are quite interesting. I want to understand why the artifacts and the human fossils, they are segregated. So I use, so that's why I only focus on this Chinese state. So, but not like our previous work, only use the Homo and the artifacts. I use all the mammal fossils. Because for me, I think to understand what the habitat, the human, they can live in, and also maybe we need to understand what the habitat, like early Homo, they couldn't live in. So that's why I want to see like a big picture. And we just test again for this, here is the hypsodont. Their correlation with the precipitation, and then the bunodont correlation with the temperature. So it's quite significant. And we plot all these fossil sites with different 6 interval through the Pleistocene. So early Pleistocene, late early Pleistocene, for example here, to the late Pleistocene. And we use the color to distinguish like the values for the bunodont and the hypsodont and the bunodont. And meanwhile, we used the paleoclimate extracted from this modeling hard HCM 3B, to see how the climate modeling is simulated for the annual precipitation and annual mean temperature. And you see the whole pattern, they match quite well, although like I found like the paleoclimate, they simulate higher temperature than the fossil. But anyway, the pattern are quite similar. And meanwhile, I'm also interested for this, why this Gigantopithecus, this giant ape, they get extinct in East Asia around these 230 years, because these are quite fascinating for people to understand why they went extinction. So they have made books, many books, and movies. And so in order to see clear, so I show another figure. So we map all the fossil sites according to their geographic coordination and by the different age. So you see the color means bunodont low, so that's, if you understand, they are mainly referred low temperature, and the red means higher temperature, and the right panel is the precipitation. So blue means high precipitation, and the orange or red means very low precipitation. So you can see how the climate change, and meanwhile you can trace how the human change for the distribution. So I distinguish three groups. So one is like the start, it means the Homo fossils. I hope you can see the star here. And the cross means only artifacts. And then the diamond, I showed like the Gigantopithecus. You can see from the early Pleistocene, and somehow the artifacts and the Gigantopithecus, they are associated or together, so in very close. And but you also see like in the southeast China, you only found this Gigantopithecus. We don't have any artifacts and the human. And so from the early Pleistocene, human get more site in the middle part here, and a little in Yunnan, you see, but still like in this cold subtropical forest, you only see the Gigantopithecus. So no Homo and no artifacts there. the same pattern till early middle Pleistocene. And also you see like the artifacts, that's no Homo only artifacts, they expand to more this low precipitation and low temperature, so compared to other fossil sites. And from the late middle Pleistocene, the Gigantopithecus only has one site. So, and the human, you see, expand to more southeast China. So, and also the human expand much north. But if you see the value for it's still like a relative warm and relative humid condition. And when we get like early late Pleistocene, it's similar pattern like before, but from late Pleistocene, it's changed dramatically. Like human, you can see it's everywhere, so disperse the whole area. The same, like even you see the very dry and the very cold, they are human fossils. And after that, we want to predict which habitat for this fossil site they can be classified into. So we use more, except the spunodont and the hypsodont, we use two more dental ecometrics, the presence of acute lobes. That also means they have the sharp subcusp, and also another presence of the stratified, fortified cusp to create a predictor model of biomass. So this is this observation of the biomass. This is our model predict by the dental ecometrics. And you can see from generally, they are matched quite well, even we lost some details. Some very screening, but generally it works very well. And so we plot this biomass on the figure, and you see like here these six they are basically classic as the desert shrubland, and early human they are here in the early. They are only in the temperature broad mixed forest, or here also. So from this we see like early Homo, they seems living in the forest habitat, but of course I mean they have more like artifact site. That means early Homo, we explained like early Homo, they have a larger activity range than they are living range. So conclusion. So first, like early Homo occupied a fairly narrow range of the habitat. So most likely temperature subtropical forest. And so the second is Homo and the Gigantopithecus are well segregated in the different forest habitat. And the Gigantopithecus are inhabited in the rainforest, and humans prefer for the more open, relatively open forest. And the expansion of the Homo into the humid forest in the late Middle Pleistocene co-occurred with the extinction of Gigantopithecus. And the last one is lithic artifact set in the desert, temperature, grassland, and shrubland habitat. In the early Pleistocene, they represent a marginal habitat in the age of the Homo occupation. So, thank you. That's my talk.